Thank you, thank you.
I was going to do my homework.
So remember, we're behind. We're behind. So this was all grace as far as us not cramming stuff in last week, but you're supposed to catch up over the weekend. 6.4, let's go ahead and grade it quickly. Our test is on Wednesday. We're covering 6.5 today. So here we go. Thank you. You can see 8, you can see 28, and you can see 40. Anybody still grading these two? We're staying here for another second or two?
I got number 8.
We do, girl. We Gucci gang.
Can you explain 28?
Yes, please.
28 is the rule that you guys don't like because we're going backwards.
Oh.
You're going backwards from b to the u, but remember the derivative of b to the x?
Limbo.
Yeah, is b to the x times ln of b. So if we're going backwards, we can't go straight backwards until
I took the
we need the ln of b in order to be able to go fully back. So you can think about it that we're dividing by the constant, or you can think about it that we're multiplying creatively to get our rule, and then whoever's left over is going to be at the end. Does that kind of make sense?
Mm-hmm.
So I needed the ln of b, so I multiplied creatively, brought them in, that way I had the rule, that way I could go back. Any other questions on these ones? And then 40 was 0, yeah? Okay. 44, you're trying to take up the whole page, so let's take a second on him.
We all got 0. Riot.
What?
Well, I guess it's because they did an absolute value.
I thought it was, but it's -4 plus 4.
But it's total.
Did it for total, or did it ask for?
Yeah, and that's the total area. Remember the vocab on Friday, I was warning you.
So it's
Total area between, don't just say total area, say total area between, that makes a difference.
Like that pen?
So absolute value is what you needed to do. So you guys that got 0, it was good, it just wasn't what they were asking for.
I didn't write it right.
So total area, instead of 4 minus 4, is 4 plus 4, which would be 8. Number 48 and 52. 52 is a plug-in chunk? You guys are so spoiled rotten.
Square root of 3 minus 5 over 3.
I don't know, why'd you do this? It's not a blue slip, you know.
I don't even have my license.
You don't need to do it right this second, you can go look at it and give it to me.
She doesn't have a,
Like,
she doesn't have a license plate.
It hasn't been mailed to me.
Oh, that's why. You can let her know.
I know.
I say we write.
Where's Caroline's up?
Can we do our sweatshirt idea?
I do want to see it for
It actually is kind of entertaining, I won't lie.
It is.
Oh, you need to go back?
Okay, thank you.
Alright, number 58.
I got 52 right. Oh, dear.
Oh, dear, man. 58.
I just lost.
Can you explain F?
Negative. Hold on, wait.
How many problems?
This is the one where they give you a graph, right?
Yeah.
Okay.
E is, I got 126 something.
I'm getting the book open, that way we can look at it.
I can't read what I wrote for F. I guess that's right. G I got right. Why is there a positive? What? G I put right. What?
What were you doing, bud?
Oh, no, yeah, it is, because right is.
Oh, going right, is that what you mean?
And then Slater said something.
I will see.
Any boys that like killing bugs? Are there any boys that like killing bugs?
I like killing bugs.
Where?
Right here in the pencil tray, it's a silverfish, I just don't want to kill it.
A what?
It's a silver. That's not even silverfish, it's like white.
Who's are you that?
What are you? Oh, you're funny. So freshman is right. Come on. Isn't that the one that's what I need?
But I'll get my medal on Friday.
Oh, never mind.
Do you want me to put it on the window sill?
What if it was alive?
It's dead.
Well, if it was alive.
Yeah, I think that's a dead body.
Okay, you know what? Alright, guys, we'll come back to number 58 and getting the book up. Anything else? Oh, that was the last one, right? Yeah. Okay.
You're after right now.
Did you type the dots?
What was the difference of 75?
There is an answer.
How do you say I know it's one of those. Alright, kiddos, you can have your notes ready. We're going back to number 58 as soon as I get the book open, but for right now, this is where we are with trapezoidal rule. I'm applying to college. This is probably what you didn't get on Friday. I'm getting the book open, but in the meantime, this is what you guys probably didn't get down on Friday. This is about where we were. There you go. It was due.
Oh, never mind, I did my homework and it wasn't due.
Okay.
Well, I did 6-5.
Oh. Because the calendar said 6-5 because we got a day behind.
You're smart, Corey.
Did you check the calendar? Or should you just do it out of instinct?
Wait, did I already write stuff for 6? No, I did not.
Yeah.
Is it possible for someone to double major in like a science field and then also do like a pre-professional, do like 2 pre-professional like prerequisites, like if it,
Like internships?
no, like so, you know how like there's pre-med and there's like pre-law. Is it possible for someone to do both?
Oh my gosh. I don't think it's a smart idea. Because pre-law, a lot of people are planning on being lawyers, but they don't actually get a degree in pre-law. They do other things like criminology or criminal science. So I would just say like a minor in something would be a good idea, maybe even better than a major, if you're interested in both.
Steve, will you go to beautician school and also become a dermatologist? Because I'm stuck between being a hairdresser and being a dermatologist.
But you need to do beauty school at night. Or like summers or breaks or something maybe. That's a good thing.
Thanks, Steve.
Because that's less rigid than a dermatologist for sure. Alright kiddos, hopefully you're ready with your notes because I'm ready with number 58 and we will jump into 6-5 as soon as we cover this guy. So, 58, Okay, 58, we'll come back to notes in just 1 second. Hopefully you got most of them down. My question to you is the following. Where did we get stuck on 58? Okay.
58 was art?
What? Oh no, actually F is a lot like the Stanford AP, the Moss AP from last year. That you guys took, that the BC kids graded. Because a lot of you missed the idea of moving towards or away from the origin. Moving towards or away from the origin. Okay, now hold on. Let's say this is the origin. And let's say at a certain point in time, put your phones away, let's go.
No,
So,
no.
for the notes, okay.
Well, I just saw it.
I don't understand, because I was back and you guys were like, okay, be productive. I'm here. Where am I in regards to the origin from your perspective?
Positive.
To the right, or a positive displacement.
Oh, okay.
What would you need to know if I am to the right of the origin, if I am a positive displacement away? What would you need to know whether I was moving towards or away the origin? The velocity. The velocity is positive. Towards or away?
You're gonna hit the wall.
Away. If the velocity is negative.
You're gonna trip over the podium.
Towards. Now pause. So So positive is away and negative is toward. That's always true, right?
Yes, ma'am.
No. What if I'm here?
I'm gonna trip over the podium.
I have a negative displacement. I'm standing still.
No, if you go to the podium.
What would make me start moving towards the podium?
Positive.
Positive velocity. What would make me start moving away?
So you should do what?
So fun.
They're all funny.
So fun. Okay, so what are the two things, what are the two things you need to know whether towards or away?
Where the position is and where the velocity.
Where you are and what direction you're headed. So you need to know two things,
That's
okay?
motivation for life.
Now, wait, if you think about it, hold on.
Thanks, Lucy.
I'm negative.
Gotta know where
Displacement.
Put it on the calc sweatshirt.
Life lesson. Okay, so I'm on the negative.
We need to get those done.
Negative. Positive velocity means towards. So when the sign of where you are and the sign of where you're headed are opposite, you're always going towards. Can I say that?
No.
If you are negative and you're headed positive, oh, you're going to go backtracking towards the origin.
Positive.
And if you're negative heading negative,
Away.
negative position, negative rate, well then, yeah, you'd be going away from. Same thing over here. If I'm positive with a negative velocity, okay, so when the signs are opposite, you're headed towards. True? Yeah. And when the signs are together, you're headed away.
It's like when
So then looking at this, f is the integrand. The first derivative is s, which is what we're looking, oh no, we're looking at the integrand. Sorry. S. So, we need to know s is sine, and we need to know the slope sign. True? So when I ask an f, they're giving me the entire function. It's not like I'm checking at one point, I'm checking the entire thing. So let's think about this. I need to figure out when s is for moving toward and away, so we're doing both. Let's just take one interval at a time. So for this first interval, I'm looking between 0 and 4. Anybody know why I've grouped all those together? Because the slope is positive and the area is.
Positive.
Why am I looking at area? What does that tell me? Position.
Yeah.
So it's to the right because of the positive area. It's to the right and it's moving more right. So therefore, the particle is moving away between 0 and 4. The AP should have marked that point, and the AP would have marked that point. The book should have marked that point. So between 0 and 4, it's moving away from the origin because it's to the right, since the position is positive, and it has a positive slope, hence the velocity is positive. Kyle?
Why is it not
Because
the slope decrease.
But it's
it's not decreasing.
It's negative.
Where the slope is negative.
velocity's still positive.
Yeah, so the velocity is still positive there.
So you're moving towards the origin, not away. So your position.
You're looking at the acceleration, aren't you?
No, but if you're still positive, it's
Oh, wait. I haven't written this all out. So hold on. S is the antiderivative, S is the area. We're not even looking at slope, are we?
you don't need
So
to look at slope.
you're.
S prime.
That's prime.
Okay, that's my bad.
So it is 0 to 6.
That's my bad. The area is positive and the y value is positive. The area is positive and the y value is positive all the way to 6. I was thinking that this was S. My bad. So between 0 and 6, area positive and the y value, hence the derivative positive. Good. Moving away. And then when the area is negative
And it's a positive.
and the y value is negative, hence the derivative is negative, then it's moving.
Towards.
Why is it towards and not away? Because negative area and negative velocity. Shouldn't that be away?
But you're still at
You're still at that point.
yeah, 6 to 9, that's a positive area.
Explain that. No. Explain it. I know what you're saying, and I agree with you. That's the reason. But explain it so they can
You're
understand.
at a positive position. But
So
you're-
between 0 and 6, you've gotten way to the right.
Yeah, but if the area is the velocity, which is that way, and you're at a negative.
So you're moving to the left. Your position is coming negative, but have you gotten back to the origin
Oh,
yet?
no, but isn't it what you?
Towards.
You're towards. You're still towards the origin. So you're
Right.
still. So no, it's still.
Not still, because this was away from and that's towards.
Yeah. That's what I'm saying.
But some of you would have just seen the negative area and the negative sign and been like, oh, negative, you're away. No, because you're way over here. So your position hasn't gotten negative. You're just headed in the negative direction. Anyway, so yeah, 0 to 6, you're going away. 6 to 9, you're moving towards. Because if you wanted to find your position, you would have to do the accumulation, and this is not going to be overall negative when you're adding that area plus or minus this area. Was it just F that we got stuck on?
Yeah.
Okay. Now, kiddos, quick warning, when we go into polar intervals, towards and away will be a little different. But that's for another topic for another day. Okay, coming back to section 6.5, trapezoidal rule. You guys were taking notes on this just a moment ago. On our forever card last year, didn't we just put down 1/2 base times height 1 plus height 2?
Yeah.
Yeah, I think we just did 1/2 base times height 1 plus height 2. So what is this mess over here?
That's the trapezoidal rule.
That's the trapezoidal rule because it says, now wait, pause, trapezoidal rule is only a thing when? What does this symbolize? Delta x is b minus a over n. What kind of problems does that not allow for? Well, Riemann sums, it technically is still Riemann sums, but we can only use this when? Given, yeah. We can only use this when we have an interval and we're splitting it up into equal subintervals. But what if they give us a table where it's already been split up for us and it's not equal and we have no options? We can't use this. We have to use just 1/2 base height 1 plus height 2. So the AP, we know that they love to give us tables for Riemann sums, so that's why we just stuck with this with trapezoids last year. But if there was something where we were able to do it by hand and choose, yeah, we would go ahead and make it all equal. So all the bases, b minus a over n, would be equally spaced. So we could factor out the 1/2 from everybody, could factor out the base because it would be equal. And then when we go to accumulate all of the heights, we would only have one of the far left, and we would have 2 of everybody else. And I'm basically summarizing what the rule says up above. Which is a great rule and all, it's just not very practical for the AP exam, which is why I just stick with the basics of the area of a trapezoid.
Why is there 2 in the rules?
Agreed. I don't understand
I'll show you with the picture. Because with trapezoids, you have to use both heights to connect. So this first one is only used in the very first trapezoid, but the second one is used not only in the second trapezoid, but it's also used in the...
Oh, that's how
Sorry.
they did it.
The second y value is used not only in the first trapezoid, but also in the second. So when we pull out the 1/2 and the base, and we're just adding together all of the y's in use in all of our area formulas, we're going to have only one of those, but we're going to have this one used twice, this one used twice, the next one used twice,
No, one.
but the last one is only used once.
Wow.
And they have used the trapezoid rule, like I think they're throwing it in like a concept-y question, like once or twice. I haven't seen it very often. So, the tail ends, those heights are only used once, but all the in-betweens are shared in double. Okay? Now, that's what this basically says, and what this is basically describing this is all just, once again, another way of approximating the definite integral, the area under the curve. Corey, how many Simpson rule problems were there?
I just did trapezoid rule because I was the same thing.
That makes sense.
2, 1. I don't know, just for homework for the problem. I don't think mine right.
Okay. Yeah, I didn't think there were very many.
I'm marking myself right.
Way down. Oh.
Alright, kiddos, I want you to go ahead and approximate. Approximate the area under the curve using trapezoids with n equals 4 and then n equals 8. You can use the rule if you want. You can use the old-fashioned, hey, it's time for A1, A2, A3, A4, just plug it into the trapezoid.
Because I don't know what the end of the values are. I knew that in my head.
No? I'm not allowed to zoom in yet. Sorry, guys, I'm trying.
Dang it, Gabby. I'm sorry.
I know the answer.
What answer? The approximation? So I'm going to go ahead and do it two different ways. I'll do it my old-fashioned way, which is the way that I personally learn. Just between 0 and pi, cutting it into fourths. Nice thing with trapezoids is they use both the left and the right endpoints. So you should see the beginning and the end pretty clearly with the term. Bless you. But as some of you that love using your graphing calculator can attest, that's kind of tedious to plug in. So most of us would go ahead and shortcut with the 1/2, would go ahead and shortcut if it is equally spaced with pulling out the base. And then if you go to add together the rest, you would have sine of 0. Exactly. Plus 2 sine of pi over 4. Plus 2 sine of pi over 2. Plus 2 sine of 3 pi over 4. Plus, nope, not 2, because we're at the end, right? This would be pretty easy to program, just as far as
Program.
Jason likes to program stuff. It's just not going to be super practical for the AP. So kiddos, that was why. Well, because the AP is not going to use equally spaced, so like, there wouldn't really be a time to plug it in properly.
You never know.
I used to do base like
You could plug it in if you're trying to like approximate a definite interval and it was doing overload. Go team. What is it? 1.096?
1.896.
Oh, 1.8. So kiddos, without a number line, without setting up A1 through A8, which would be super tedious, can we go straight to using the trapezoidal rule for n equals 8?
You could.
Okay, so let's just go straight trapezoidal rule, area.
Does it really do a summation?
Maybe. The problem would be with the doubles though. But you could go ahead and just have it. Problem would be with the doubles, because it's not strict. But you could go ahead and do it for like all the in-betweens, and at the very end, add that and add that times the, I mean, you could do that. Okay, what are we going to do?
Pi over 16.
Not pi over 16, too crazy. Oh, you already multiplied by 1/2. Is that what you did? Got it. Times. All right. What are our
Sine
insights?
of 0 plus 2 sine of pi over whatever that is, plus 2 sine of pi whatever that is.
What would that be?
Pi.
I can't.
1 pi over 8.
Miss,
So that'd be
you can
2,
zoom
right?
in. I finished it. Oh. Oh my.
Oh,
Now you're done. I'm kidding, Gabby.
I'm not talking about you.
Okay.
all right. So we had sine of 0. Then count over 1 pi over 8, which would be sine pi over 8, right? What was the next one?
2 sine of pi, I don't know what number.
2 pi. Well, no, you have to think about it, because you're cutting 0 to pi into 8s. So 1/8, got it. 2/8 would just be pi over 4. 3/8.
3 pi over 8.
Yeah. 4/8.
4 pi over 2. 4 pi over 2. 5 pi over 8. How many?
Think for job.
Good job.
6 pi over 8.
I missed
I know you by your legs.
Do you have another one? 6 pi over 8, 7 pi over 8. And then the last one would be, woo! There we go. And we have our approximation, right? So once again, when is this useful?
When the bases are equal.
And when the bases are unequal, all bets are off. You go back to the good old geometry of 1/2 base times height 1 plus height 2. Done.
What's the answer to this? Did anyone find it?
Did you guys help? No one's trying.
Never heard of her. Okay, wait, you got 1 point, so definitely got 0.05 for this.
Did anybody else try to plug in the first one? We have two very, very, very. Oh, sorry, 1.89. Do you put big old parentheses?
It's hard to get.
And a double?
Nope, I'm in degree.
Oh, that's not gonna work.
Love physics. I'm in degree.
So before the AP exam, we're reminding each other that we're in radians.
Wait, I still didn't get that. No, are you?
Well, I happened to drop that class file. Yeah.
Okay, I want to show you the idea of Simpson's rule. I think I only gave you 1 or 2 homework problems with Simpson's rule. We actually totally ignored it last year when it kind of showed up in homework, and I said, oh, just ignore the Simpson's rule. It's not going to be on the test, but I do want to show you the idea. It's not going to be for every part. It's not on the AP. But I do want to show you the idea. It's taking the trapezoidal rule one step further. It actually helps introduce something that's coming second semester. So that's why I'm showing you.
Did you say that this one was not going to be on the AP, or was?
This specifically is not. The concept that is introducing will be. So it's just kind of like my way of introducing. Approximating not just with linear. Linear? Can I say that? Linear functions? Not just approximating with geometric shapes. Let's put it that way.
Are there some words in that?
Oh, you guys haven't dealt with the half. Should even say the half. The fourth of it. The tenth of it. Because in math, not. What's the written variance? The value of the math is directly related with the amount to which it can be proven. And there's a lot of things that sound good to those with only a basic understanding, and yet I don't know how to make this into an adverb or an adjective. Have some sort of logical fallacy that would make it very destructive if ever further applied. So math came from philosophy in some ways, and that's deeper thinking of not just the what but the why.
Why does 6 2 2?
So if you tell a mathematician, like, that makes sense, and they're like, well, that's great, but why do you know it's true? How do you know it's true? How do you can use it?
Why constantly the 14?
Oh, as to where it came from. Hey, kiddos!
My favorite.
The theorem that you've written, right?
Yes, ma'am.
Evaluating integrals of polynomials of degree 2 or less. Where does the expression down below come from? You have the integral from A to B of some sort of second degree polynomial, or it could actually be a linear, or it could even be a constant, because A could be 0, B could be 0, C could be 0. True? You end up with the following. What does P stand for?
Function.
Function.
Wait, is that quadratic?
The quadratic on the right. I mean, you are plugging into the quadratic, if that's what you're looking at.
Yeah, but the squares are gone. PA plus 2p.
This dy is
And plus 2.
Well, you're trying to strictly integrate. The idea is for quadratics, linear constants, any integral could actually be stated in this geometric way. It's not specifically dealing with antiderivatives. So some of you are trying to solve for the antiderivatives and figure out how that would apply. And yet, if you were to actually find any definite integral between A and B of a quadratic or lower degree, you could also plug into this formula as well. I think it somewhat comes from completing the square, but I might be wrong on that. But here's the idea. If that is true, which it is, if that is true, then that forms the basis or the foundation for the following. If that is true, but there is a way to solve the integral of a quadratic geometrically, now it's only the quadratic or lower, but from that follows that we can approximate area under not just using shapes like rectangles and trapezoids, but we can also actually use parabolas in order to approximate. And why does that actually maybe even give a 1-up from trapezoids? Because then you have curves. With parabolas, you can have curves.
I don't understand. Why is that a 2?
Do we have to write that?
You can write down if you choose.
I don't get why there's a 2 there. Instead of a 4.
It's based on the part that came from before in the sense of how we can summarize over here. How we can summarize the area under. So if we were to add, if it was evenly spaced, if we were to add one subinterval underneath the parabola plus another subinterval underneath the parabola, the P of A would stay. He'd be the lone man out. You would have the 4P times A plus B all over 2 for like a subinterval of the whole interval. But then this guy would get shared. So there'd be 2 of them. So this PB would be here, but then it would also be a PB for the next one being the start of the next subinterval. So there'd be 2 of those, and then there'd be 4, then there'd be 2 of the other, and then there'd be 4. And you keep on going all the way until you get to the final height, which would be like the first one, the lone man out. So the idea is that it's similar to trapezoidal rule, which is why they cover it together, in that you are adding together approximations for different subintervals of a whole or of a larger interval. But if you guys notice, we're not just approximating with the trapezoid. We're approximating with the parabola. And that would make the approximation even better than a trapezoid, because a trapezoid would be linear, and there is no getting closer to the curve with the linear connection. No.
Why is it 4, 2, 4, 2?
Think trapezoid again. When you have the trapezoids back to back to back to back, something gets shared, right?
Yeah.
A certain height. So on this one, no. What gets shared is this guy. So your first endpoint is lone. This is the inner part of the formula, which doesn't have to do with the endpoint. This one is the right endpoint, which is going to get shared with the next left endpoint of the next partition. And so you're going to have 2 of the PBs, and then you're going to have, this next one is going to have, so if I was, problem is this is for the whole one. So if I was to do P of x sub 1, or x sub 0, I guess, plus 4P of x sub 0 plus x sub 1 all over 2, plus P of x sub 1. And then if I was able to pull this out of everybody, B minus A all over 6, because it's going to be the shared collection then, or the shared variable. The next one would start at P sub x sub 1. And it would also have its own for x sub 1 plus x sub 2. Then you'd have P of...
So you're technically adding.
So these 2 are going to pair up.
Yeah, it adds with the other.
So you have 1, 4, 2, 4, 2, 4, 2, 4, all the way until you get to the second endpoint, which is P of x sub n. So it's one step above the trapezoid. And you guys know the trapezoids are one step above the rectangles. But it's just saying that parabolas can actually be solved geometrically as well, so they could technically be used as a better geometric approximation because of the curves. And that just introduces you to the idea of, to approximate or to get closer to a curve, you can actually use other curves, which is the idea for second semester that we're just barely introducing. going to be spiffy once we get there, because then you're able to approximate transcendental functions like sine and cosine and e to the, I don't know if like that, with polynomials. So, how would we use Simpson's rule to approximate? We would plug into that nasty formula. Our a would be 0. Our b would be pi. And our n. Oh, did I totally take it away? Took it away. We have to choose an n. Oh. So we use n. Now, guys, we're not going to actually do Simpson's rule. I've given you the foundation to it so you can try on 1 or 2 of the homework problems. It's not going to be on the test, but it is a great introduction to getting closer to more complicated curves using polynomials, specifically a quadratic.
So on the graph,
Right, because you have like a, here would be your A, and here would be your B, and then you've partitioned it into however many partitions you need, and so then each of the x of 1s would just be the little heights in between, like we used with sine when we did this guy. It'd be the same like x values that you're putting. You're just getting a better approximation. So cool. What? Kiddos, listen up. If you see error in your homework, I just wanted to show you that. You can look in the section as far as a quick way of finding what that error would be. So you can look at the section. There's a theorem for it. Yes, ma'am. If you come up against it, but it's not going to really be present.
did we turn up the 7 homework for Bible?
All right, okay. We're on 6 5. All the questions we have. Error, look at the section.
Oh, it's running.